Hey QE Decoders, this is Michael. In the last video we started building your own game in Jinaga, and we walked through how we might update the tic-tac-toe game in order to build a couple of different variants. The easy mode was something like Connect 4, and the hard mode was something a bit more like Battleship. Today we're going to complete the easy mode example and build the Connect 4 game. So let's dive in and see where we are. Now that we've gotten back to our regular tic-tac-toe model, let's use that exact same model to build Checker Drop, our version of Connect 4. I've got a fresh, clean branch. Now let's kick things off by asking for a little bit of help with the product requirements. I used ChatGPT for this. So I asked it to write a concise description of the Connect 4 rules with two modifications. Call it Checker Drop instead of Connect 4, and use the standard checker colors red and black. Then I asked it to create some pseudocode. This is going to be the key to changing the tic-tac-toe behavior into Checker Drop behavior. And then I got some pseudocode out of it. This is everything I need in order to bring that into Cursor and start to modify my tic-tac-toe game to turn it into Checker Drop. Currently within the application, I have this tic-tac-toe file, and this computes the tic-tac-toe game state. It has the list of moves, the players, and whether or not the challenger starts. Now, some of this logic is going to be useful for any two-player turn-based game. So I want to extract that from the tic-tac-toe specific logic so that I can just replace tic-tac-toe with Checker Drop. So this little section right here to determine the current player and the next move, this is the part that is universally applicable to any kind of application. So we've got some stuff above and some stuff below. Let's just do a little bit of refactoring here. I'm just doing this old school with my actual fingers and stuff. And there we go. It's at this point that I want to bring in that pseudocode. All right, I've got this Checker Drop plan, and it's got the pseudocode for calculating the game state. That's all I need for right now. Let's go to my AI assistant over here, starting a brand new chat, and we're going to bring both tic-tac-toe and Checker Drop plan into scope. All right, I've told it to update the plan in @CheckerDropPlan. That brings that into context. In order to include the steps to modify @tic-tac-toe TS, bring that into context, replace tic-tac-toe with Checker Drop. Let's see what it does. Now we have our plan all laid out, and it's telling me all the wonderful stuff that it just did. Let's go ahead and review this by opening up the Markdown preview. That really helps to read things over and make sure that everything works exactly as we expect. Now I can see here that it interpreted my prompt as going even further and updating the game board UI. That wasn't my intent, but how could it know that from the limited prompt that I gave it? So that's why we like to do things step by step, see what it's about to do, and then apply constraints before we move on to the next step. So in this case, I want to apply the constraint that we don't want to go on to the UI components quite yet. So let's focus on game state calculation and unit tests, remove UI components from the plan beyond changes necessary to make the app compile. And now you can see it has updated the plan. And so now we've got a complete plan that focuses just on game logic and testing and integration. All right, we've got the pseudocode in there. We have removed the integration testing. So this looks like this is going to be a successful run. Now, you could try to one-shot this. In fact, that might be interesting to see just what happens. I usually find that one-shots are not terribly effective, so we'll go ahead and give that a try. And if that doesn't work exactly to our liking, then we're going to come back and we'll do things one step at a time. So we can see it going around and around in circles, and it's making a lot of logical errors. It's having a hard time figuring out what the challenger starts Boolean is all about. It looks like it finally realized that when the challenger starts Boolean is false, the challenger should not start. And so the opponent should make the first move. And so now it's got to update the logic and update the tests in order to capture that particular requirement. Now it looks like it's getting stuck in a loop where it's creating test scenarios that create the wrong kind of win. It's creating horizontal wins rather than diagonal wins. It wants to test the diagonal check, but it keeps accidentally creating intermediate wins along the way. So this is another great example of why I will often prefer to do things one step at a time rather than do a one-shot. Because one step at a time, I could say write the tests, and then I can evaluate those tests, and I can find these kinds of errors and correct them before it moves on to the implementation. But it's doing a good job of finding those issues on its own, so I'm going to let it play out and see if it's able to create a decent set of tests and implementation. All right, it thinks it's finished. It's writing out a summary, everything that it was able to accomplish. It happened to flash the last test, showed some failures, so I don't think it's actually finished. But let's inspect what it came up with and see what we can see. So here we find a really interesting function, create win scenario. This gives me an array of moves. Game as any. Okay, so it's ignoring the fact that a move has a game predecessor. We don't care about that, so let's go ahead and just shove an empty object into that. And then for each of the different move indexes, we play at a position. So red plays in column 0 and black plays in column 1. Red is the first one to make it to 4. Okay, that creates a very simple win scenario. I like it. So here we have the win detection. I mean, that is a passing test. However, that's not a horizontal winning scenario. That's a vertical win scenario. The vertical win scenario right here creates test moves 0, 1, 0, 1, 0, 1. It's the same scenario. Okay, so it got confused about those scenarios. I would probably want to go in and fix that. Now, I think I would just write that code myself rather than trying to prompt it into creating these kinds of win scenarios. And now we've got our problematic diagonal win scenario, and we can see that it tried to do a 0, 0, 1, 0, 2, 0, 3, and red immediately wins, but that's horizontal. Okay, so that's not a valid diagonal win scenario. It's really having a hard time with kind of visualizing the board. I mean, this is a language model after all. It's not actually thinking or reasoning or doing any kind of logic. So I can understand why these things would be very difficult for it. Yeah, I'll definitely go in and I'll create my own win scenario to test diagonals. But one other interesting thing is that it did this by creating that array of moves, whereas here we can see that it's got a create test moves helper function. That would be much simpler to reason about. So I'm going to rewrite this using create test moves. And here we have a draw condition where it fills up the board by alternating columns. So it's basically going to create a checkerboard pattern in the board, which is going to create a whole bunch of diagonal wins. So I suspect this test is failing because this should not produce a draw. Okay, so we got down to the bottom. It looks like most of those tests are reasonable. It's just the logic behind horizontal, vertical, diagonal, and the draw condition. So we'll need to go back and do some manual testing there, or manual test writing there, rather than prompting. All right, so let's fix things up a bit. This helper function, create win scenario, I don't want to be so specific about this win scenario. I'll delete that function, and instead I've got my horizontal win here that was using it, and it wasn't horizontal at all. So I'll fix that, and then we've got show to ignore moves after the game is already won. I'll go ahead and replace this with a proper create test moves. So this is going to be, we'll change the name to winning moves. And that should be a nice simple test. Now we come back to this one, and instead of create win scenario, we want to create test moves and actually produce a horizontal win. Now the easiest way to do that is to have the black player always play on top of the red player, and then we will make a horizontal win rather than playing in alternate columns. So if we just do 0, 0, 1, 1, 2, 2, 3, that should put all of the red pieces across the bottom and then 3 black pieces on top. And so the game should be won by red. Let's go ahead and test that out. So let's run our tests, and we see that we've got this nice little debug output. That was really cool that it added that debug output so that we could see what was happening. And yeah, so this one clearly diagonal win. That's not a diagonal win. No, these are both wrong. But we have a positive outcome for should detect a horizontal win and should detect a vertical win. I would like to see those little debug states. So what have we got here? Format board. That's what I want to see. Let's format the board in the other ones too. I mean, that's just fun. Here we go. So win detection. What we expect to see, horizontal win. That's the horizontal win we expect. And then vertical win. That's the vertical win we expect. And then diagonal win with a positive slope. So let's change this to a game board that actually has a diagonal win with a positive slope. 0, 1, 1, 2, 3, 2, 3. There we go. So we've constructed a proper diagonal positive slope win. All right, and it looks like it is passing. It has detected the winner, and the game is over. So let's move on to the negative slope. Boom, boom. All right, so playing through that, we can get a negative slope win for red. Now, you know what? I should probably have a little bit more variation here. Let's not make this a win for red, but instead a win for black. And we'll do that by just sticking a different move right here at the beginning, and boom, now that becomes a win for black. Let's change this to black to complete the test, and now the test passes. Okay, so I think I've got all the tests passing. Let me just run them all in the test runner here. And oh, that's right, the draw position. Here is the board position that we end up with because we stop as soon as black wins. So let's now shift row 2 over by 1, which means that we are making an extra red move and one fewer black move, which throws things off a bit. I think I've got it. Any diagonal win on this kind of a pattern is going to require the middle column. So let's change the nature of the middle column. So how about as we go across the row, we do 0, 1, 2, we skip 3, and then we do 4, 5, 6, then go back to 3. And that interrupts all the diagonals. All right, so now let's just write that code. If we do that, then we should get this interrupted pattern down the center. Oh, and that apparently has created a win for red. Where's the win for... Oh, there it is. All right, back to the drawing board. Okay, let's go with a variation of this that's even simpler. So we're going to do 0, 1, 2, and then we're going to do 6, 5, 4, 3. Yeah, so we're just going to come from both ends. Oh, well, that means that it's going to do a diagonal on the 6, 5, 4, 3. All right, I've got another shifting pattern in mind. I want to have red, red, black, black, red, red, black. And then on the next one, black, black, red, red, black, black, red. So the way I'll accomplish that is I will go 0, 2, 4, 6, and then come back 1, 3, 5. And that'll fill in the pairs, leaving one at the end. It'll be an odd number, so then when I go to the next row, it will be the colors reversed. And if we do that, then we should have, boom, aha, perfect. We have a draw. Nobody won because the angles are all wrong. Okay, well, no wonder that this was the hardest thing for the AI to get right. That was a lot of reasoning. Yeah, that's not the sort of thing you can expect an LLM to do. So, okay, we've worked through all the tests. I should be able to push this big old test button right at the top and It'll run through all the tests. It'll output the things I told it to output. And when it's done, we've got a big green check mark at the top. All the tests pass. We now have the game logic working. The next step is to integrate it with our custom hook. So coming back for the next chapter of Build Your Own Game AI-Assisted Development. We'll see you then.